Good day, everyone. My topic for now is about Maclaurin series. This is Girlie De Soliva from BSED Math 3B. Maclaurin series. Let f be a function that is infinitely differentiable at x is c, that is, the derivatives of f to the power of n of c exist for all positive integers n. The Maclaurin series for f is the Taylor series for f above 0, that is the power series. The summation from 0 to positive infinity of a sub n x to the power of n is a sub 0 plus a sub 1x plus a sub 2x squared plus so on, where a sub n is equal to f to the power of n of 0 over n factorials for all n. Examples. 1. Find the Maclaurin series for the functions f of x is sine x. F of x is sine x. First derivatives is cosine x. Second derivative is negative sine x. Third derivatives is negative cosine x. And fourth derivatives is sine x, since further derivatives repeat the cycles of four functions. Evaluate the function and derivatives at c. So f of 0 is 0, and the first derivative is 1, second derivative is 0, third derivative is negative 1, and fourth derivative is 0. Next is write the expanded form formula of the Maclaurin series, which is f of x is equals to f of 0 plus f prime of 0 times x plus f to the power of 2 of 0 times x squared over 2 factorial plus f to the power of 3 of 0 times x cubed over 3 factorials plus f to the power of 4 of 0 times x to the power of 4 over 4 factorials plus so on. Next is sine x is equals to 0 plus 1x plus 0 minus x cubed over 3 factorial plus 0 plus x to the power of 5 over 5 factorials plus 0 minus x to the power of 7 over 7 factorials. Just substitute of every derivatives of the second step, next step. Next is sine x is equals to x to the power of 1 over 1 factorial minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial minus x to the power of 7 over 7 factorial plus so on. And then write the series using summation notation, which is sine x is equals to the summation from 0 to infinity, the quantity of negative 1 to the power of n times the quantity of x to the power of 2n plus 1 over the quantity of 2n plus 1 factorials. Next example, number 2. Find Maclaurin series for the function f of x is cosine x. So, f of x is cosine x. The first derivative is negative sine x. The second derivative is negative cosine x. The third derivative is sine x, and the fourth derivative is cosine x. Since further derivatives repeat this cycle of four functions. Evaluate the function and derivatives at c, which is c is 0, so f of 0 is 1, and first derivative is 0, second derivative is negative 1, third derivative is 0, fourth derivative is 1. Write the expanded form formula of the Maclaurin series, which is f of x is equals to f of 0 plus f prime of 0 times x plus f to the power of 2 of 0 times x squared over 2 factorial plus f to the power of 3 of 0 times x cubed over 3 factorials plus f to the power of 4 of 0 times x to the power of 4 over 4 factorials plus so on. So cosine x is equals to 1 plus 0 minus x squared over 2 factorials minus 0 plus x to the power of 4 over 4 factorials plus so on. And cosine x is equals to 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorials minus x to the power of 6 over 6 factorials plus x to the power of 8 over 8 factorial minus so on. Write the series using summation notation, which is cosine x is equals to the summation from 0 to infinity, the quantity of negative 1 to the power of n, x to the power of 2n over the quantity of 2n factorials. So 3, find Maclaurin series for the functions f of x is equals to cosine x squared. The cosine x is equals to the summation from 0 to infinity, the quantity of negative 1 to the power of n, x to the power of 2n over the quantity of 2n factorial. Since cosine x squared, then cosine x squared is equal to the summation from 0 to infinity, the quantity of negative 1 to the power of n, and the quantity of x squared to the power of 2n over 2, the quantity of 2n factorial. Since it is cosine x squared, then we change the value here as x squared too. So the answer is cosine x squared is equal to the summation from 0 to infinity, the quantity of negative 1 to the power of n, x to the power of 4n over the quantity of 2n factorials. Next example is find Maclaurin series for the functions f of x is equals to x cosine x. So like earlier, copy the Maclaurin series of cosine x. Then since it is x cosine x, then we put x here. So it is x cosine x is x, that's times the summation from 0 to infinity, the quantity of negative 1 to the power of n, x to the power of 2n over the quantity of 2n factorial. And the answer is x cosine x is equal to the summation from 0 to infinity, the quantity of negative 1 to the power of n, x to the power of 2n plus 1 over 2, the quantity of 2n factorial. That would be all. I hope you learned. Thank you and God bless everyone.